So rates are derivative. So related rates are where derivatives are connected to each other or related to each other. So let's look at what we've got here, just like overview here. So we've got a cube surface area is changing, and that means the side length is changing. How are they related? Air is being pumped into a spherical balloon. Okay. The volume increases. How fast is the radius increasing? Well, that makes sense. If the volume is increasing, the radius is increasing. The length and width of a rectangle are decreasing. And the length and width of a rectangle is decreasing. So how fast is the area decreasing? So what we see are changing rates and how they're related to each other. So this is my little training wheel kind of deal. So we want to get from the words what the rate is that we're trying to find. And it's always going to be d over dt. So let's changing with time. So what is the rate cube's side length changing? Okay, so I'm going to say dx over dt is what I want to find. So now I have to think about what is x. X is the side length. And so I need to think about the equation because this letter here, x, has to be in the equation. So if it's a cube's surface area, so I'll just call it S, that's going to be 6x squared because you know that's 6 sides of area x squared each. All right, so what is the given rate? So they give us something per second. So that's a given rate, and they're telling us the surface area is changing at 72 inches squared per second. So I'm just going to say dA over dt is 72. And we don't need to carry the units along. All right, here's our find rate. Here's our given rate. We have the equation. So now there's going to be some when information, some instant in time. We're taking the picture and we want to know how things are changing at that instant. So the when information is when x equals 3. Don't use that until after the derivative. So sometimes I even encourage students to just circle it, save it. Okay, so here we go. So I'm going to take the derivative of this with respect to t, right? So derivative with respect to t, that gives me ds over dt. And then here I do a little bit of chain rule, right? 12x times dx over dt, right? I brought the 2 down, 12, x to the 1 power times the derivative of the inside. I put S and I changed the letters to A. This is a pit to fall into. It truly is. So this is the surface area I'm really thinking of, right? So S here. Okay, so ds over dt is 72. And I'm going to plug my when information in here. So I have 12 times 3 dx over dt. So this gives me 72 divided by 36 is dx over dt. So the signs should make sense. If the surface area is increasing, the side length should be increasing. So positive derivative means increasing. All right, let's move to the next one. So we have air pumping into a spherical balloon. So this is something you're going to need to memorize, the volume of a sphere. And we see that the volume increases. Okay, so that's our given rate. So dV over dt is 100. You don't need to carry the limits along, but that helps me understand that that is the volume. So what is it I'm trying to find? How fast is the radius of the balloon changing? I have the formula here, so I know I need to use the letter R for the find rate, right? So that's dr over dt is what I'm trying to find. Got my equation. So now I'm looking for what is the when information. When the diameter is 50. So I'll save that for later. So now I'm going to go take the derivative. So let me write the problem or the equation down again. Take the derivative with respect to t. dv over dt, carry along this big ugly number, and then take the derivative of r cubed, which is 3r squared, times dr over dt. So I see that the 3's go away, and let's see what I can plug in. 100 equals, then I get 4 pi, and what do I know that r is equal to? Oh, now that I've done the derivative, I'm allowed to use the diameter is 50, so I know that means the radius is 25. And then put in dr over dt, and then you just get to divide by everything, right? So 100 over 4 pi, 25 squared, dr over dt, and that's a fine answer. Remember, you cannot use r prime or v prime anywhere in this section where we're taking derivative with respect to t. It's not just me, my personal preference. It's just illegal math move, I guess you could call it. Okay, here, length of a rectangle is decreasing. Oh, decreasing. If a rate is decreasing, and I can be given 2 rates, I'm going to say that the dl dt, let me make it capital L, dl dt is -4. So when a length is decreasing, we want to assign it a negative rate. Its width is decreasing, dw dt, at -2. Okay, so there's 2 given rates. What's the find rate? What are we asked to find? How fast the area is decreasing. So find dA over dt. Equation of the area of a rectangle. Well, that's not so hard. So area of a rectangle is A equals length times width. And what's the when information? Oh, look at that. They give me 2 things for the when. L is 14 and W is 15. Okay, so I'm going to take my equation. Let me make some room up here. Take my equation and take the derivative with respect to t. Get rid of all that. Okay, oops. Okay, so I'm trying to find dA over dt from this, right? So let me just write the equation, L times W. So dA over dt is first, you see the product rule, right? D second plus second, D first. Okay, so let's plug what we know in. So dl or dw over dt is -2. dl over dt is -4. Oh, and look at that. They give us the L and the W, don't they? L is 14, W is 15. So there you go. If I add those numbers together, it is a negative number, right? So that is decreasing.